Hello everyone. In this module we will see FreeCAD software and learn why choose FreeCAD. FreeCAD is a powerful free and open source computer aided design software that enables us to create complex 3D models. Whether you are a hobbyist looking to design parts for 3D printing or an engineer seeking a cost-effective CAD solution, FreeCAD offers a range of tools to bring your ideas to life. In this module, we will explore the pros and cons of using FreeCAD, delve into its history, compare it with other software packages, and guide you through the installation process and interface tour in the subsequent modules. This is the first part of our 10-part Introduction to FreeCAD series that will walk you through creating various physical objects in this open source computer aided design program. In the series we will cover the following topics like getting started, an interface overview, sketches, constraints, part design workbench, shape binders, expressions, spreadsheets, heat set inserts, patterns and boolean operations, revolutions, pipes, lofts, sweeps and lofts with guide curves, curved surfaces, assembly workbench, and much more. A brief history of CAD and FreeCAD. In 1950s, the term computer-aided design was coined by computer scientist Douglas Ross, who envisioned the use of interactive graphical displays for design. In 1960s, the release of DAC-1, one of the earliest commercial CAD programs, laid the groundwork for modern CAD systems. In 1990s, Matra DataVision released Open Cascade Technology (OCCT), an open source software development platform for 3D CAD, which became the foundation of FreeCAD. In 2001, Jürgen Riegel began developing FreeCAD utilizing OCCT and released the first version in 2002. 2015 to present, continuous development and contributions from a global community have enhanced FreeCAD's functionality and stability. You can learn more about FreeCAD history on its website. Then why use FreeCAD? Before diving into the software, it is important to understand why FreeCAD might be the right choice for you. Pros: free and open source. Unlike many commercial CAD packages, FreeCAD is completely free to use. Even for commercial purposes, its open source nature means you have complete ownership of your work. Cross-platform compatibility. FreeCAD runs on Windows, macOS, and Linux, making it accessible to a wide range of users. Feature-rich, it offers a comprehensive set of tools capable of handling complex designs, including parametric modeling, which allows you to modify your design parameters and have the model update automatically. Active community and development. Continuous improvement and the updates are made by a dedicated community of developers, enhancing stability and adding new features. Now comes the cons of FreeCAD. Steeper learning curve. The interface may not be as intuitive as some commercial packages, requiring more time to learn. Stability issues. Being open source, it might be prone to occasional bugs and crashes, especially when using development versions. Less polished interface. The user interface may not be as refined or user-friendly as those found in commercial software like Creo, ANSYS, SolidWorks, etc. Fear complex workflows. Other paid tools might offer specialized workflows out of the box, such as curved surfaces, finite element analysis, and manufacturing. Now comparing FreeCAD with other CAD packages. When choosing a CAD program, consider factors like cost, features, ease of use, and platform compatibility. If you are comparing FreeCAD, cost, free for personal and commercial use, its platform, Windows and macOS and Linux, availability, features, parametric modeling, open source, extensive community add-ons, ease of use, moderate learning curve due to less intuitive interface. Now comes the commercial alternatives. like SolidWorks, industry standard with extensive features but costly, starting around $4,000 plus annual fees and Windows only. Autodesk Fusion 360 offers a free version for personal use and affordable commercial licensing of $680 per year, but requires cloud storage and is not open source. Tinkercad, a beginner-friendly cloud-based tool ideal for educational purposes but limited in advanced features. Then comes the open source alternatives like Blender, excellent for animation and organic modeling but not primarily designed for mechanical computer-aided design. OpenSCAD uses scripting for modeling, ideal for programmers but may not suit those preferring a graphical interface. Then in the subsequent modules we will see how to install FreeCAD for Windows, macOS and Linux. Also we will see launching FreeCAD in different operating systems. Also we will explore the interface like workbenches, interface components, customizing preferences, etc. Then we will follow creating your first object. Some tips for success. First, save frequently. Regularly save your work to prevent data loss. In FreeCAD, use constraints wisely. In Sketches, apply geometric and the dimensional constraints to define your design precisely. I advise you to primarily rely on geometric constraints, example symmetry, parallel, constant, over dimensional constraints, example distance, radius where possible, as this helps keep your designs more parametric without having to change lots of numbers should you need to make updates. Explore workbenches. Don't hesitate to explore different workbenches to discover additional tools and capabilities. The FreeCAD forums and online communities are available or valuable resources for troubleshooting and learning advanced techniques. FreeCAD is a versatile tool that, despite its learning curve, offers a robust platform for 3D modeling without the financial barriers of commercial software. By understanding its interface and capabilities, you can begin creating intricate designs suitable for 3D printing and other applications. In the next session, we will cover discovering FreeCAD. We will delve deeper into designing parts using the other workbenches and introduce you to the more advanced features.